So we're doing geometry this week, and we've got some new instructors, I guess. So we'll do our introductions first. So I'm Ethan Chuang. I'm a year 13 student at Auckland Grammar School, and I did do mine and did. I was an instructor at mine and did last year, and I'm doing it again this year. And I guess outside of academics, I play a lot of badminton, so I've included a photo of me playing badminton. So yeah.
I'm Tian Lan Gong. I'm a year 13 student at Auckland Grammar School, and I'm taking triple science and maths this year. And I also love human rights. So if you guys like human rights, you should message me. And yeah.
Okay, so we'll in this tutorial we'll basically just be covering like very basic geometry first. So we'll just be doing similar and congruent triangles first. So yeah, we'll just start off with congruent triangles.
Okay, so congruent triangles are triangles that have the same angles and the side lengths. And so basically these triangles are basically the same. So if you were to superimpose two congruent triangles, they would be the same. And there are three conditions that imply that a pair of triangles are congruent. So first one is SSS, which is side, side, side. And then the second one is AAS, and then the last one is SAS. So I'll be going through these in detail. Yeah. So SSS means that each pair of the corresponding sides are equal. So if you look at this diagram here, you see that AC is equal to QR, and that AB is equal to PR, and that CB is equal to PQ. So the notation here, you'll see that AB has one line that's marked in the middle. So this means that it shares the same length as PR, which also has one line, and then QR has three lines, and then you'll see that AC also has three lines. So that means AC is equal to QR, and then lastly, you'll see that PQ has two lines in the center here, and then that means it's equal to CB in magnitude. So does anyone have any questions so far? Also, guys, if you have questions, you can just drop them in the chat, and then Ethan will be able to answer those questions. Okay, so no questions. Okay, so the next condition for congruent triangles, so it's AAS, so this basically means angle, angle, side. So when two pairs of angles are equal, and then one pair of sides is equal, notice that since triangles have a fixed angle sum of 180 degrees, having two pairs of angles equal means that the third pair is also equal, because we know that A, we know angle A and angle B, then we can just find angle C using 180 minus angle A, then minus angle B. So again, here's some new notation. If you've William Kidd, what if the sides are not equal? William Kidd, can you elaborate on your question, please? What do you mean by sides? William Kidd? Okay, never mind. So the notation here, if you look at angle A and angle Q, they both have two lines. So this is indicating that these two angles are equal in magnitude. And if you look at B and angle R, these angles both have three lines. So that means B is equal to R in terms of size. So if we know that, if we know that one pair of sides are equal, and that we know that two pairs of angles are equal, then we can know that these triangles are congruent. So make sure that you have the right side. So the two sides have to be opposite the same sided angle. If not, the two triangles are not congruent. So does anyone have any questions so far? No questions. Okay, sweet as boys and girls. So can you move on to the next slide, please? Okay, so the last condition is SAS. So SAS means side angle side. So when two sides are
You
equal,
have free data?
No.
Okay, let's turn it on.
Yeah, the top one has some.
so two sides are equal and the angle in between the sides are equal, then we know that two triangles are congruent. So a common mistake that people make when dealing with SAS is that they don't consider the angle in between the sides. So if you look at the diagram here, the top one, you'll see that angle A on the right triangle is not in between the two sides that are known. So therefore, you have to be careful with dealing with these triangles because the angle must be in between the sides. So yeah. So William Kidd has a question. What is congruent? So since you joined a bit late, you might have missed the definition. So a congruent triangle is when the triangles, like, so let's say we had two pairs of, sorry, so, it's okay. Let's say we had two triangles, right? And if we know that if we superimpose them, so if we take the two triangles and we place them together like this, we'll see that they have the same dimensions in space, and therefore they're equal in size and shape. So the angles and the sides are equal. I mean, yeah. Okay, next slide. Okay. So here's a practice question. So check for yourself. So which two triangles are congruent to each other? So I'll give you guys like 1 minute or something, or 2 minutes to do this question. And also try to apply the conditions that you learned earlier. Okay. Just 2 minutes or 1 minute. Okay, so moving on. So the triangles that are congruent, so the two triangles that are congruent, so it's the yellow one and the blue one. So as Alistair said, from SSS, which is side, 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 we know that these triangles are congruent because this length, so 4.5 is present on the blue triangle, and then they both share 5 and 3 on the other triangle. So therefore, these are congruent. And I noticed that someone said that orange is also congruent. Since the sides are not equal in magnitude, you can't say that they're congruent, but they are similar, which is what we're going to cover next. Yeah. So does anyone have any questions?
Wait, I think someone
No
said on the
questions?
previous slide that the angles don't line up. Wait, this slide. Wait, what is this
Wait,
question?
what?
As Leon said on the slide before the previous, I don't think the angles line up. Are you talking about like the bottom diagram?
The one before this one.
Or the one before this one? Wait. This one.
Yeah, on the left triangle, the sides are like to the left of the equal side, but on the right triangle, they're on the like the right of the equal side.
Oh, the right triangle is they are the same triangle. It's just that the right triangle has just been like rotated a little bit. So it's still the same triangle. So if you see here, like
No, it looks like it's flipped.
Yeah, even if it's flipped, it's still the same triangle. Like congruent only
Oh,
means
is it?
like the sides are equal and the angles are equal. It's not like
Okay.
I mean, I guess you could argue that you can't superimpose them on top of each other, but like congruent just means all the sides are equal and all the angles are equal. If that answers your question.
Okay.
We'll move on then. All right, yeah.
So here's another problem. So use the three conditions that you guys learned earlier. So to explain why the four triangles are congruent. So this diagram depicts a small square that's inscribed in a larger square. Yeah. So I'll give you guys like 2 minutes. Yeah.
Has everyone had enough time to just like think about the question, or does anyone want like a little bit more time to like think about it? Because we can go through the question together. Um, all right. I'll just go through the question now, I guess, because I think you guys have had some time, I guess. So wait, I'll pull up this. So I'll annotate the whiteboard here, I guess. So does anyone have any ideas? I guess let's just walk through it together. So, what's the first thing you guys thought of when you looked at this question? I guess you guys can use your mics if you want, by the way. You don't have to type in chat. Okay, they all touch the same point, so the sides are equal. Do you want to be a bit more specific here? Which sides specifically are equal? Come on, guys, let's say something. AH. AH, EBFC, and what was that? DG. So you're saying this side, this side, this side, and this side are equal. Okay, but why are they equal though? I don't. It's not immediately obvious why they're equal. If you kind of get what I'm saying, do you know why they're equal? Like, how do you know for certain that these sides are equal? All the sides of the square are equal. So that means that AB equals BC equals CD equals AD. That doesn't necessarily mean that AH equals DG equals CF equals BE, if you kind of get what I'm saying. Because what you've just told me is that like this side equals this side. That doesn't necessarily mean that like CF equals BE, if you kind of get what I'm saying. Right, yeah. So all the sides of the inner square are equal, yeah. So I'll just rub this out first, I guess. So the HEFG is like a square, right? So then that means all the sides are equal, right? So we know that these four sides are equal here. That's a good observation. That's a good start, because if we want to prove these triangles are congruent, we want one of side angle side, side side side, or angle angle side. We've got one side that's equal now. All the angles are the same because the flat sides have 180 degrees. Could you please elaborate on that statement? Interior angles of small triangles. You know, can you just like use your mic? I feel like that'll be a lot easier. Oh, okay, you know it's fine. Okay, what I assume you're trying to say, right, is that, for example, right, you know how angles on a straight line equal like 180 degrees, right? So if I like label this angle X, right here, we know that this angle is 90 degrees, right, because it's a square. So then what is this angle right here? Can someone tell me what this angle is? 90 minus X, right? Oh, this is some beautiful handwriting right here. Okay, so then what is this angle then? X, right? Because we know that ABCD is a square, so this angle is 90 degrees. And since the angles in a triangle add to 180 degrees, that means this angle here is also X, right? So we now have a pair of equal angles, right? And then if you just repeat this process around the entire square, you'll just find that, you know, 90 minus X here, and then X over here, 90 minus X over here, X over here. So, and then go around the circle, right? So basically, now we have all the, I guess, the necessary information. So then what's the final step to prove that like all these triangles are congruent? Right, they all have the same angles, right? So then we know they have all the angles are the same, and we know that they have one pair of sides are the same, which are all the hypotenuse are the exact same. So then we can just say by angle, side, these four triangles are all congruent. If everyone followed that, I hope. Does anyone have any questions, I guess? Because all these triangles have the exact same angles, and then they have one pair of sides that are, you know, equal. Do the sides not have to be opposite the angles? Oh, for angle side, it can just be any side, because if two angles are the same, then it means all three angles are the same, and then just having one pair of sides that's equal is just enough. So yeah. You can say angle as well. It doesn't really matter, but like most people just say angle. So does anyone else have any questions? Does everyone understand this?
Sir, I have a question, sir.
Yeah, yes.
How does the criteria for proving congruence versus similarity differ?
We'll go into similarity next. Don't worry. I'll answer your question will be answered in due course. I'm assuming everyone else has no questions, so we'll just move on. I'll go back to the slide. All right, we'll start on similar triangles now. So we've done congruent triangles where the shape of the triangle is the exact same and the size of the triangle is the exact same. But similar triangles are when the shape is the exact same, but the size differs, right? Which means that the two triangles will have the exact same angles, but they'll just have different length sides. So if you see in this diagram, I have two equilateral triangles. They all have angles of 60 degrees, but the side lengths are all different, right? So the first triangle has a side length of 12 centimeters. Second triangle has a side length of 18 centimeters. So they're not congruent because the sides aren't the exact same, but they're similar because they're the same shape. If you can't get what I'm saying, I guess a way of like intuitively thinking about it is like one triangle is kind of like a scalar multiple of the other. It's just like the same thing, but they just like enlarged it, if you kind of get what I'm saying. So the three conditions for like identifying a pair of similar triangles are like very, very similar to congruent triangles as well. They're called side, 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 angle, angle, and side, angle, side as well, but it's slightly different to congruent triangles, I guess. Does anyone have any questions so far? Nope. Okay, I'll continue. So you know how I said that like an intuitive way of thinking about it is like the one triangle is kind of like a bigger version of another triangle, if you kind of get what I'm saying. So basically the ratio between the pairs of sides of similar triangles are like constants. Okay, I'll go back, right? So you know how the ratio between like 18 like xz over mn and like xy over ml and yz over nl, they're all equal to 18 over 12. So you kind of see how the ratio between the pairs of sides are always constant. It's the same thing for like all pairs of similar triangles. So the ratio between the sides is always going to be equal to each other. So if you see in this diagram here, like QP over AC equals PR over BC equals QR over AB, all equals K. So we call these two triangles similar. Does anyone have any questions so far? Is that one like is that understandable, I guess? Yeah, it's kind of similar to congruent triangles in a way, but like instead of the sides being the same, it's like the ratio between the sides are the same. Oh yeah, and then the curly line thing just means similar. Yeah, that's notation I forgot to mention. My bad. For congruent triangles, there's a similar notation. It's like an equal sign, but with like 3 lines instead of 2 lines. So it's like 3 parallel lines on top of each other, I guess. That's like the symbol for congruency. Okay, we'll move on. So, and then we have angle, angle. So you know how I said similar triangles, all 3 angles are the same. So if you have 2 pairs of angles that are the same, that automatically means that the third pair is also the same because the 3 angles must always add to 180 degrees. So for example, here, if you have YZ, then the third angle must be 180 minus YZ. So that's just angle, angle, I guess. Yeah, I'll move on. And then we have side, angle, side, which is kind of like the congruency one, except instead of having 2 pairs of equal sides, you have the ratio is equal this time. So we see here, the ratio between the 2 pairs of sides is n, and you have to have the angle in between the 2 sides again, kind of like side, angle, side. Is another common mistake, I guess. Yeah, congruent triangles are like technically also similar, I guess. That's true. No questions so far? Okay, cool. So then we'll have a quick recap. So please find the side length S in both cases. All right. So why is the first one s equals 3? Can someone explain where they got the number 3 from? Yeah, someone show their working, please. If you put this in an exam, you would get 1 out of 2 marks. You want all the marks. You need to show all your working. Come on, guys. Six over 2 equals 9 over s. Okay, but why is that equation true though? Like, who said that the ratio between the sides must be the same? We can't just assume that the ratio is the same. See, the two angles are the same. So you have to use angle to first state that those triangles are similar, and then you can use the ratios. You see what I mean? You have to first state that the triangles are similar by angle, and then you can use your ratios. Can't just be assuming things out here, Gotta have rigorous steps. Okay. And then, okay, what about the second one, I guess? Give your answer with working. You see, Eli is right, they're similar by side, angle, side. Can everyone see that? Got the 4 divided by 2 is 2, 10 divided by 5 is 2, so the ratios are equal, and then you got the angle in between them that's equal, 35 degrees. So that means the two triangles are similar, so you can now use the ratios, so 6 over s equals 2. So that means s equals 3. Yeah, does everyone understand that? No questions? Okay. We'll move on then. You know what, William, you speak on this slide.
Okay, guys, here's some very common strats. So strats means strategy. So when you're problem solving, the number one strat is to see which triangles are similar first. So like upon inspection, like first inspection, just try to see which triangles are similar. And then number two, do the triangles actually contain the desired quantities? So let's say you're looking for a specific length that's stated by the question, and try to look for triangles that contain that length, so you can find relationships and stuff. And number three, how are the geometries of the triangles related to each other? So in this case, well, they'll be like similar, right? And sometimes you would need to be able to develop some quantitative and algebraic relationships from similar relationships in order to find the final answer. Yeah. All right, next slide. Oh, does anyone have any questions? If you have any questions, drop them in the chat. Yeah. All right, next slide.
All right. So basically we've covered all the theory now, so we're just gonna do like questions for the next hour. So here's the first question. Yeah, William, you can present this.
Okay, so here's a very important question. So we have some questions here. For S for similarity, do their sides need to be equal or just the same? Same ratio, yeah. And quantitative just means like numerical relationships. So like a ratio or like an equation, yeah. So here's the question. So if I have two triangles, I and II, are known to be similar. Furthermore, it's known that the length of the median to the longest side of I is 6, while the length of the median to the longest side of II is 9. So what's the ratio of the area of I to the area of II? So I'll give you guys like 2 minutes to like maybe like 4 minutes to think. All right.
Wait, does everyone know what the median is? Okay, I'm assuming everyone does not know what the median is. So the median is like kind of like a line from the vertex that like splits the opposite line in half. If you kind of get what I'm saying. Maybe I should draw up a diagram for this. Does everyone need a diagram, or is like, are we all good? Is that yes to all good, or is that yes to diagram? Oh, wait. Let me just. I just get a new one. So we have our triangle. So the median is from here, here, splits this line in half. That's the median, this thing right here. Yeah, wait. I'm seeing a lot of answers, so I'll just kind of like go through the question, I guess, for everyone. Let me just redraw this diagram. Wait, oh. Alright, so we got two triangles. I just draw a random triangle. We got another triangle. And the question states they're similar, right? Yep. So then the median to the longest side of I is 6. So we should, that's 6. That's 9. We're trying to find the ratio of the area. All right. Okay, I'm seeing a lot of answers, but where's the working, guys? You guys don't listen to me. I'm very disappointed. Come on, guys. What's the first step, I guess? Where are you guys getting these numbers from? If x is half the length of the longest side, 6x. If x is the halved length of the longest side, then the areas are 6x and 9x. Wait, I'm not understanding this solution. I'm sorry. But I think what you have done here is I think you've assumed that like this is a 90-degree angle. So then you just let this EX and then the area is 6x. But that's not necessarily true. We didn't say that this is a 90-degree angle yet. See, this is why showing it working is very important. Right, does anyone have any other ideas, to start off the solution? Okay, so the question tells us that the two triangles are similar. So what can we, what information can we gather from the two triangles being similar? That's very important. I'm not going to give you that for no reason. Angles are all equal? True. Let me, angles are all equal. Okay, what else does it tell us, I guess? The ratio of the sides are equal. Okay, that's basically what it tells us. Okay, so where do we go from here? Now we know all the angles are equal and the ratio of all the sides are equal. What can we discern from this information? the angles on the inside are also equal to. Okay, why? Why are the angles on the inside also equal? Because the ratio, it's not very specific. What ratio? Okay, let me just label these like sides for you guys. Make it maybe make it a bit easier for you guys. A, B, C, D, E, F, G, H. Okay, which ratio is equal? Like which ratio between which sides? It is split through the middle. Okay, what does that mean? What does it being split through the middle tell us specifically? BD and FH. BD and FH. Okay, so what is the ratio of BD and FH equal? Like, this on its own does not tell us anything. BD, FH, what else? AD and EH. AD and EH. Okay, but how do we know that the ratio between AD and EH is like equal to the ratio of the sides? You get what I'm saying? Let's start from the beginning, guys. You know, let's build our way up to the solution like step by step. Okay, let's not rush ahead. You know, angle BDA is equal to angle DAC. BDA is equal to angle BAC. Wait, DAC. BD. BDA. DAC. But why? D is in the middle of B and C, and H is in the middle of F and G. What is that supposed to mean? I'm not understanding. You guys are just saying statements. Yes, D is indeed in the middle of B and C and F and G. And yeah, what does that mean, guys? Come on. Someone lay out all their steps for me right now. Because I feel like you guys know the steps, I guess. You just don't know how to like coherently say it, which is a problem. Because if you're doing this in an exam, it doesn't really matter if you've solved the question, because if you can't write it down for your examiner to see, there's no point. All right. BD equals DC and FH equals HG. Okay. Okay, you know, I'll just go through the solution, whatever, that's fine. So we know that the triangles are similar, right? So the information that gives us is that AB over EF equals AC over EG equals BC over FG, right? Is everyone following along so far? That's a true statement, right? So we also know that BC is equal to like 2BD, right? I'll just start this on a new slide. BC equals 2BD. And then we also know that FH or FG equals 2FH. And then you can kind of like sub that in here. 2BD over 2FH. So that cancels, right? Everyone following along so far? So then now what you notice, right? I just isolate these two actually. AB over EF equals BD over FH, right? From this big thing here. So you notice, AB over EF, and then we have BD over FH, right? And we know that the angle in between these like pair of sides is equal, right? So then by side angle side, we know that ABD is similar to what is the triangle? EFH. Does everyone kind of understand that, I guess? Where did you get 2FH? Yeah. Does everyone understand where I got this statement from? Like the rigorous steps. Okay, my handwriting is a little bit bad. My bad. Okay, do I need to try rewrite this, or do I need? You know what? Basically, ABD is similar to EFH. You know, maybe I'll just try make it a little bit neater. Does everyone understand how I got there though? That's like the important thing. So I feel like many of you guys like guess that without like actually doing the rigorous steps, if you can't get what I'm saying. So then now we know that ABD is similar to EFH by side angle side, right? We also know that the ratio between EH and AD is the same, right? So is the same as this. So we know now that this is equal to AD over EH, right? Which we know is 6/9 or 2/3. True so far? Everyone following? Maybe my handwriting is a bit atrocious, but I hope everyone's following. So now we know that AB over EF is equal to 2/3. So basically the ratio between the sides of the big triangles is 2/3, which is what we wanted. And so the ratio of the areas is 4/9. Yes, that is the right answer, but I didn't see any working. That's the problem. Yeah, the sides are 2/3. So we showed that AB over EF is equal to 2/3. And then since we know AB over EF equals like AC over EG equals BC over FG. Yeah, the ratio of the sides is 2/3. Does everyone understand? Kind of. Yeah, understand. Not really. I think I missed a step. Which step do you think you missed? Okay. If anyone has any extra questions, you can just come ask me after. That's fine. I'll move on to the next question, which is this one. Have a think about this question, I guess. What the heck?
You guys need more time? Does anyone have a solution for this so far? Or I'll give you guys 2 more minutes. Yeah, okay, guys. So what um wait, Ethan, can you switch to the Jamboard? Okay, so first off, do you guys know which triangles are similar? So just say in chat which triangles are similar. Okay, so BDE and triangle BAC are similar because of AAA, because we know that these two triangles both share the angle B, so that's one angle that they share. And we also know that BED, which is the right angle, and BCA, which is also a right angle triangle, these two angles are equal, so we know that these two angles are equal. So AA, we know that these two triangles are AAA, these triangles are similar. So just have a look. Yeah, I'm seeing some correct answers here. Okay. So wait, I can write on the board. Well, okay. Just one second. Okay, so if you guys have a look at the diagram here, we know that, all right, I think it's this one, right? So we know that DE is equal to 4. So this is equal to 4, right? And we're also told that AC is equal to 6 and BC is equal to 8. So BC is equal to 8, and then AC is equal to 6. And we're asked to find BD. So we're trying to find this length here. So the first step is we already know that BDE and BAC are congruent, right? So we know that BD, we know that BD over what equals AB equals what? Is this right? So we know that the ratio of BD to DE is equal to BA to AC because these two triangles are similar. Now we're asked to find BD here, so let me just have a look at the chat. BA is 10 Pythagoras, and the ratio is 3 to, yeah. So yeah, that's a good solution. And then Leon, yeah. Okay, so I'll just go with the solution. So we know that AB is equal to 10, like you guys said, because of Pythagoras. So BC squared plus AC squared equals BA squared because BAC is a right angle triangle. So therefore, 6 squared plus 8 squared is equal to 100. So the square root of 100 gives me the length BA. So this length here is 10. All right, does anyone have any questions? All right, no? Okay. So from this relationship that I put out earlier. We can just sub in these lengths into the equation. So I know that BD is my unknown, so I'll just make BD my x. And then I know that DE is 4, which is given in the question. AB is 10, which I found by using Pythagorean theorem. So BC squared plus AC squared, and then square root that. And then we know that AC is equal to 6. So solving for x, can find BD. Okay. Does anyone have any questions so far? Can you up your game? That writing is atrocious. Oh, sorry guys. My bad. Okay, so no questions. Okay, we'll move on to the next question. Bro, this is disrespect.
I think we're like running a bit short on time, so maybe we'll just like go through this question together if you kind of get what I'm saying. So do you guys have like the diagram copied down? Just like copy down the question, the diagram, and then like the answer to the last one was like 20/3 or something, I think. Yeah, just like draw this diagram out and put down all the things, and then I'll just go through this question together with everyone. Maybe it's a bit faster that way. I'll just like paste the question. Yeah. All right, guys. What are the two similar triangles? Can anyone see a pair of similar triangles? Tell me what the pair of similar triangles is. Is ABC and ABF. You just name 3 triangles. Like ABF and EDF. Okay, ABF and EDF is similar. They are similar, but why, guys? Come on, tell me why. Okay, just tell me what condition it is. Is it side, side, side? Is it angle, angle, side? Or is it side, angle, side? Wait. Angle, angle, side is not even right. It was the parallel line things. Yeah, is it side, 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 angle, side, or angle, angle, angle? My bad. Not angle, angle, side. That's congruent triangles. Which one is it? Angle, angle, angle. Yeah, so basically, we know this is a parallelogram, right? So we know that these sides are parallel. So you know alternate angles, this angle equals this angle, right, guys? And we also know that vertically opposite angles across a point. So we know this angle here is equal to this angle. So we know you got 2 angles that are the same, so automatically the third angle is the same. So we have angle, angle. All the angles are the same. So we know that EDF and ABF are similar. So then how can we use this to find the side length of FD, guys? Angles EDF and AFB are both 90. Not necessarily, are they? I actually don't know. Finding AF first. That's true, yes. Okay, so basically we know that EDF and ABF are similar, so I'll just write out the ratio you get. So you know that AF over FD equals ED over AB, right, guys? This is true from the ratios for the similar triangles, right? And we know that ED over AB is equal to 4/16, right? So we know that AF over FD equals 1 over 4. Right? Is everyone following so far? Oh, I did do it the wrong way around. You're right. As my bad. Mistake from me, unfortunately. So then this is 4. There we go. Much better. Sorry, guys. All right. So how can we use this to find FD? DF to AF is 2 over 8. That's true. But how are we gonna find FD? Because it adds to 10. That's so true. AF plus FD equals 10. Right, guys? Because this side is equal to this side. Right, guys? So basically, you can just turn this into like an algebraic equation, I guess. So if you let AF equal like X and FD equal Y, you know, like X plus Y equals 10. And then like X over Y equals 4. And you can just like solve simultaneously to find FD. Is everyone following? I won't do the algebra, I guess. You can do it in your own time. This is a geometry tutorial, not an algebra tutorial. But this is kind of like the main idea, I guess, to solving this question. Does everyone like follow? Does everyone understand how this question works? Can we move on? Okay, cool. I'll move on to this question. Oh wait, yeah, this one right here. Oh, who is this guy? Oh. All right, cool. Everyone do this question. Everyone like draw the diagram again, and I'll go through the question with you guys again. All right, basically, I hope you guys drew out the diagram. It basically looks like this. Did everyone get the diagram down? Yeah. Wait, I just deleted it. All right. Here's the question. Okay, so given that, oh, wait, are we trying to find this? I'll show that. Okay, so we have a square DFAE. Okay, what similar triangles can you guys find again? You know, when you look at these questions, always look for similar triangles. So what are the similar triangles do you guys see? All the triangles is not very specific. Name some actual triangles. So we have BDF and CDE. Okay, why are they similar? BDF similar to, what did you write? CDE. Okay, why are they similar? All right, just say side side side, angle angle, or side angle side. Which one is it? So how would you know it's side, side, side? Because you don't know what the actual side lengths are. Yeah. You don't actually know anything about the sides in this question. You don't know like the lengths of like BD, BF, DC, so on and so forth. All you know is that like DF equals FA equals EA equals D because it's a square. So basically it's angle, angle, angle because you have like, okay, this is a square, so these sides are parallel, right? So this is a corresponding angle. So these two angles are equal, parallel line rules, and then 90-degree angle here and here. So then angle, angle. So these two triangles are similar. Yep. And then okay, what is another pair of similar triangles? You guys can see. Does anyone see any other similar triangles they could possibly use? BDF and BAC because of angle, angle, angle. Yep, that's right. So you see, these two angles are the same, and then this 90-degree angle, this 90-degree angle. So yeah, BDF is also similar to ABC. Actually, all three triangles are actually similar to each other because yeah, BDF similar to CDE, similar to ABC, all by angle, angle, angle. So basically from this, you just get a bunch of ratios, right? You guys can write it all out, but you get like BD over, AC equals whatever. It doesn't really matter to be fair because we're interested in X, right? So let's just write out the ratios that interest us, So we have X over AC equals like say BD over BC, right? Because okay, this is like DF. Right? From the BDF is similar to ABC, right? Everyone following that kind of? Well, we're trying to show that, prove this statement right here. Actually, it might be easier for us if we just like algebraically manipulate this first. So, AB plus BC over AB times BC equals 1 over X. So then X times AB plus BC equals AB times BC. Right? I guess this would probably be easier to show, because of the fractions. So basically this question is just doing a bunch of like ratio chasing, I guess. You just list out a bunch of ratios until you get this basically. So I guess we can try X times BC equals BD times AC. That's what you get from this, right? So we get this, right? Oh, this. That's true, right? We also can get from, which one is it? I think CDE maybe? From CDE similar to ABC, we get that, okay, well, this one's X. So we get DE over AB equals CD over BC, right? From CDE similar to ABC. Does everyone understand where I got this ratio from? DE here is X. Everyone following? So then we could just algebraically manipulate this one again. So we get X times BC equals CD times AB. Right? Wait, no. Oh, wait, this is right, yeah. What is everyone talking about in chat? This only proves if DCE is 45 degrees. What's going on? We don't know CD equals DB. Yeah, that's true. We're not assuming this is a median here. True. The visuals. Maybe I should like rewrite this out. I don't know. Do you guys want me to rewrite this out? Fair enough. Do you guys want to have a go at it? If you do, you guys want me to like keep explaining, or do you guys? Okay, maybe you guys should have a crack. Just like play around with the ratios. It's actually good practice, I guess. Just like have a play around with the ratios and see if you can, get the result. I guess because maybe I shouldn't be helping you guys through this. I don't know. Just like have a play around with the ratios. Because like you have this stuff, right? And you can just list out all the ratios and just have a play around with it, maybe. Because like this is pretty common in like math questions, I guess. Just like having a ratio chase, Just have a play around with the ratios, see what you get. We can have like a group solving session. We're doing this together. Has anyone like gotten anywhere with their ratio chasing? Has anyone like let's just like make a list of all the ratios everyone's actually gotten. Maybe this could be very instructive. Okay, what ratios has anyone been like playing around with, I guess? Hello. A B. Okay, maybe I should type this out. My handwriting's a bit bad. Wait, where's the text? AB over X equals AC over X. Is this true? Probably is. Okay, let me just. Okay. So like X plus BD over DCX. So you're saying this? DC times X equals AB. Where'd you manage to get this one from? Let me just copy and paste the question here, actually. Maybe a bit easier. Wait. Oh, I didn't even. Oh, I gotta draw this. Wait. No. Redraw the question. Is this C A B? Is this D? I've forgotten which the sides are. D F E. D F E. Alright, so you're saying X plus BD over DC times X equals AB. How did you manage to get that? BD over DC equals, okay, so you're saying BD over DC equals BF over X. BD over DC. BD over DC equals BF over X. That's true, yes. So you get X times BD equals, well, maybe I should type this out again. X BD equals BF DC. AB over X and divided by AB to get 1 over X equals something. That's true, yes. Does anyone else have like any other ratios that they've done? Hello? There's no one. BC equals AB plus AC. That's not even true, bro. Does BC over CD? Does BC over CD work? BC over CD. BC over CD. Oh yeah, what does BC over CD equal though? BD over BC. BD over BC. BD over BC. This is not, I don't think this is true, is it? BC over CD equals BD over BC. And I'm not sure this is true. I'm sorry. I'm not sure where that came from. Guys, remember that BD over BC equals 1. Not. Did you assume that this is a midpoint? I don't think it's not the midpoint. That's a problem. Yeah. Wait, so the original thing we're trying to prove again was X over AB plus BC equals AB times BC. Is DCE equal 45 degrees? Not wait. Be DCE equal to 45 degrees? Not necessarily, no. Yeah. Yeah, it is 1 over x equals 1 over AB plus 1 over BC, but I've just kind of like rearranged it, if you get what I'm saying. Yeah. I'll go over the rearranging again. So we have, I think the equation was like 1 over AB plus 1 over BC. So we like turn this into one fraction, right? So we have BC over AB equals AB. Wait. Right. And then we cross multiply to get AB times AC equals X times BC plus AB. Oh wait, I made a mistake, my bad. It's supposed to be BC. Whoops.
Yo, guys, I'm just gonna jump in to help Ethan. Okay.
Oh, I made a
What?
mistake. It's BC, guys. My bad. I think I lied to everyone this entire time. Wait,
Bro,
whoops.
bro.
Wait, that's my bad, unfortunately. I lied to everyone. Wait, no one picked up on my mistake. No.
Wait, guys, I'll go over the solution. Just Ethan, can you open the Jamboard? Like, just go to the first page. Okay, so I'll just redraw the diagram. So, oops. Wait. So this is my triangle here. So ABC. You guys can see this, right? Okay. So just one sec. Oh my. Just one sec. Okay, so I've labeled the lengths of the side of the square as x, and then I'm just gonna let this point be D. So I know that triangles BD, well, I'm just gonna call these points E and F. Just one sec. We know that BDE is similar to DCF because they share this angle here. So BDE is equal to DCF because DE is parallel to CA. And then we also know that DFC and BED are 90 degrees. So by the AAA condition, we know that these are similar. So we can form a relationship here. So we know that AB to AC, which is this long length, and then AC. So the ratio is equal to x over AC minus x. So AC minus x, that's just CF. So the length of DF to CF is equal to the ratio of AB to AC. So we get this equation here. So does anyone have any questions?
Wait, they can't see what
Or
you're.
Ethan, it's can you like refresh?
Wait, let me just reload.
Can you guys see this? So okay, you guys might have missed it, so I'll just go over the solution again. So we know that BDE is similar to what? Is similar to DCF because we know that BDE is equal to DCF since DE is parallel to CA. And we also know that these are both right angle triangles. So therefore, we know that the ratio of AB to AC is equal to DF to CF. So I'm just gonna rewrite this. One sec. So this is equal to DF over CF, but I've replaced DF with X and then CF with AC minus X because we know that the length of the square is X. Wait, Ethan, can you just refresh the Jamboard? So I don't think it's shown. Um, okay, can you guys see this? Okay, so Josie is asking, is DF and DE the same? So yeah, because from the question we know that DE and DF form the lengths of the square. Okay, so moving on. So we have this relationship here. So that. So if we rearrange this equation, we get, just give me a sec, guys. Okay, so this is just rearranging the equation. And so if you just do some algebra, you'll get the desired equation in the question. So I'll just walk you guys through it. So I'll just write all the steps. Just give me a sec. Okay, can you guys all see this? Wait, Ethan, can you oh no, August. Okay, so does anyone have any questions? So what I've done here, so I'm taking the first equation, so this is what I found earlier using similar triangles, and I'm just rearranging these terms to give the final equation. Any questions? Let me just check. No questions. Ellie is asking, how is AC minus X equal to 1 minus X? Okay, I think so. It's kind of hard to see when it's written like this. So I'm just gonna rewrite it. So AC minus X over AC. So if you look, if we can break down this fraction, we see that this equals 1, and then this gives me X over AC. So it's just splitting the fraction to give the same result, but it's in a different form. So does anyone have any other questions? Yeah, so 1 minus bracket X over AC. Yeah. Yeah, thank you, Dawn, for writing the summary. So just have a read, everyone, and yeah. Okay, so does anyone have any other questions regarding this problem? Okay, no questions. Okay, so we're gonna end the tutorial now, and asking if you guys want to do more questions on similar triangles next week, or you guys want to, cover, like circles,